All right. Hello, everyone. My name is Joep Meindertsma, and thanks for the introduction. Thanks for being here, too. I'm going to tell you a bit about AMdEX. At first, I think I already had enough of an introduction, so let's get right into it. So, AMdEX stands for the Amsterdam Data Exchange, and it's a collaboration between the Amsterdam Economic Board, AMS-IX, DEXUS, a new company, University of Amsterdam, and SURF. And basically, AMdEX is working on two problems. The first one is give people more control over their data. And the second one is make it easier to share data under specific conditions. So we are trying to solve these problems in two ways. First, by creating new software, and secondly, applying these in real use cases. So the first mission, more control over data. We're kind of losing control over our own personal data, and we think it's worth the effort to try to fix that. So let's jump back in history. This is a picture from 1989. You're looking at Tim Berners-Lee right next to his very first website. He basically invented the web browser, the web server, HTTP all in one go. And the way he envisioned the internet, it kind of looked like this. It's really a decentralized graph. A bunch of connected servers all linking to each other, where everyone would have their own server, where web pages are hosted. But if we look now at the internet, about 30 years later, it looks a bit more like this. There's a smaller amount of nodes, and these are far more important in weight in what they do with how users interact with them. What we're missing is the connections between individual people and individual organizations and their machines. So how did this happen? Well, all these platforms used the web to create web applications, which all had their own APIs. And because the web didn't evolve fast enough, these organizations all wanted to create their own ways of communicating between front-end and back-end. And this actually helped create data silos. Some of them are very intentional data silos, but often these are not very intentional. So to demonstrate this, imagine if I want to get a picture from a friend using Facebook, I don't ask my friend for a picture, no, I ask Facebook for that picture. And it's actually something we're very used to, but in a way, kind of weird. This problem is not unique to social media platforms. It happens pretty much every time anybody creates some sort of web service. And that's a real shame. Often people want to actually make their software interoperable, but they have barriers in doing that. So the easiest way is to make something that's not very interoperable. We think the solution to this problem is basically give people more control over their data by separating the applications from the data. Basically give people their own server, much like how the original idea for the web was. That way, people would have their own database, their own place where they would store application data, and applications are just layers built on top of that reuse the same thing. And that way, people can decide who gets access to their data, they can share it directly with others, and you get a lot of performance benefits as well. You can maybe use an old smartphone, put it in your closet, and that would be your own personal data server. Our second mission is to enable more data sharing, because people aren't sharing enough data. You might think we're not thinking about private data here, but most of the time organizations aren't sharing their data for various reasons. We'll dive into that. There are basically three categories of data. The first one is things that we really want to share. So for an organization, that may be marketing stuff, product descriptions, maybe some happy customer stories. There's also data that we don't want to share, such as very privacy-sensitive data, or data that's sensitive for competitors, or maybe unhappy customer stories. Then there's a third category of data, which is actually the biggest one. That's data that we might want to share, but for some reason, we actually don't. And there's a lot of reasons why this might category actually contains very valuable data, but people aren't sharing it still. And that's because sharing data is actually very costly. I mean, technically, it can be very cheap, but imagine all the things that you have to do. First of all, you probably have to prepare your data. Maybe you have to anonymize it or clean it up. You have to do marketing for it, make sure your data set is described, it has the right labels, you might make it very discoverable. Then you have to gain trust. People may want some guarantees that your data is good enough or it's actually accurate. And then after that, you still have to share the data, which means you host it, invite people, do some sort of user registration. Then you may need to do access management. And finally, you maybe even want to do managing payments if you want to get paid for your data. So one of the things that we try to do is create software that basically deals with all these steps and makes it incredibly easy to do so. Secondly, and also you need to check the usage afterwards. But if we want to share data in this might category, people will only want to share it if certain conditions are met. For example, people only want to share data with a specific person, or maybe when a specific payment has been processed. Or maybe only they want to share data with a group that can verify some sort of attribute. For example, a doctor who can prove they have a degree may get access to your own medical data. Or maybe you only want someone who agrees to use it for a specific purpose or won't use it for some other specific purpose. So the way we describe these sort of data agreements is basically twofold. We either have legal text, which is what we use most of the time. It's hard to read, it takes a lot of time. And on the other hand, we have legal data. And this is more of a new field, but a really interesting one. Because legal data has a couple of advantages. If you have machine-readable conditions for data agreements, you can filter them, you can sort through them, which makes it easier to find a specific data set matching the things that you want to do with it. And also, it can be evaluated by machines. So machines can actually check if the conditions are met, if you're actually holding up your end of the deal. For example, check if a payment has been processed. So, what do we actually do? Well, mostly we're building software. So one of these first things we're going to be building is eFlint. This is being developed at the University of Amsterdam. Shout out to Thomas, not sure if he's here. Yeah, he's in the back, cool. So he's working on a new language to describe legal constructs. Basically, this is a machine-readable format to have executable statements. So you can use this for these conditions that I was talking about earlier. You can automate legal checks, you can automate verifications, and basically make the legal stuff less of a hassle, so it can be done way more fast, and you get way more checks, so more people can actually share data. We're also working on the DEX pod. This is an open source personal data server, or personal online data store, which is what pod stands for. This is based on the Solid technology developed by Tim Berners-Lee. It's basically a software that you can host for yourself, where you can share data under these very specific conditions. And you can do stuff like manage your agreements, see who has used your data, who accessed it, when, and have a high degree of control over that. A second project is mostly a thing I've been working on. This is called Atomic Data. This is a specification and a bunch of open source tools, and they are designed to improve data interoperability. It basically builds upon the linked data specifications. A part of it is a performance graph database. It's meant for modeling data and sharing these data models with other people. And there's a bunch of demonstration implementations, such as a search application, real-time chat, document collaboration. And it's basically designed to show you that having a self-hosted data pod where you store all of your personal data is actually a viable thing. So some of the use cases we're doing. The first one is KLM. KLM, as you may or may not know, earns a lot of their money by doing actually maintenance for other airliners. So these airliners have a lot of potential issues with their aircraft, and the earlier you can detect what types of maintenance should happen, the cheaper it is to actually maintenance them. So predictive maintenance is a very important cost saver for KLM. But in order to do these predictions, you need a lot of training data. And these training data is owned by all these different airlines, and they're competing with each other, so they don't want to share their data unconditionally. So this is actually, you can already feel what we're trying to do here. We're trying to help them create a data marketplace where these airliners can share their data under their conditions, describe their data sets, and ultimately get better maintenance predictions out of this. A second user case is from the University of Amsterdam. So researchers create a lot of research data, but for various reasons, they may not want to share it. The main one is legal issues, such as copyright or ownership, privacy, and sometimes also purpose limitations. So we're trying to help them create digital contracts that help them enforce compliance and use digital signatures to check these compliances as well. And for the third use case, I'm not going to tell anything about Marineterrein. Tom is way more fit for doing this, so please give it up for Tom.
Thank you. Thanks. Thanks, Joep. That was a great kind of foundation for the system that allows us to now explore these types of data exchange models using urban data. So right now, as an architect and planner, I was fascinated to explore this digital world that's invisible, all these invisible layers of our cities right now. So I've had the privilege to work on the Meindertsma as a data strategist, and about 6 months ago, Joep and I started kind of coming up with these kinds of use cases that could be very compelling to see how we can utilize urban data in this platform to allow beautiful, wonderful things to happen. So I'm going to just talk about a few of the cases that we have now working in the platform. But first, I think it's important to talk about what the Meindertsma is. It's this military base just behind us here. It's about 4 acres. Half of it is active still. The other half is a kind of innovation district where they're looking at future ways of living, learning, and working. So how do we create how do we future-proof our cities? And so it's a kind of a playground, a kind of sandbox to test all of these urban technologies. And so these technologies are collecting a lot of information. What's interesting about the Meindertsma as a space, as a kind of inner city district, is that you can look at it in kind of, let's say, a few different types of ways. You've got public parks, waterfront swimming, business parks, campus, fitness, and so each of these sensors that we're deploying with the machine learning technologies or object detection, there's a lot of data that we're collecting. But how do we share that data to other people, like journalists or artists or architects or entrepreneurs? And that's what we want to explore with the AMdEX framework. So this is another snapshot of all the different types of sensors that we have. So you see the kind of range and diversity of the types of data collection that is happening. This is interesting because it's not just historic. Some cases we have 2-3 years of data. In other cases, it's real-time API calls. But these are all physical location-based, so they all affect us one way or the other. And why should we need to move beyond these black boxes? We need to move beyond hoarding all of this data. And so AMdEX enables us to kind of explore whole new types of ways to share the data in and around swimming and sports, busyness, biodiversity. There's lots of things that we can do here. So for example, the data that we're collecting is helping figure out the drones are coming. We're testing the drones and the rowboats in the water. We're also testing them in the air. We can actually plot different kinds of types of people. The biggest data set that we're now doing with the AMdEX is, of course, the crowd monitoring data. So when the system was designed together with the city of Amsterdam, the CTO office, and it's basically what it does is basically accurately counts people anonymously. So there's no recordings. It's just a kind of algorithm that just counts. It's basically a sensor. And that sensor is now connected to the AMdEX platform. So the first case is basically what you see here is this kind of interesting kind of hierarchy, or it's a infrastructure between, you have the intermediary, which is the city or the Meindertsma. And then you have the data collector. And I'm going to talk just a few cases about who those collectors are. Of course, the broker is the AMdEX exchange. And there's lots and lots of people that want access to the data. But what are the conditions to enable that transaction to happen? So for the crowd data, for example, as you see here, this is the public eye algorithm with the overlay to protect privacy. And we're collecting lots of data. We have over 3 years of data on the Meindertsma. The cities are getting hot. There's a lot of, let's say, the hot spots in the city. There's over 300 events per year organized in the city of Amsterdam with 5,000 plus people. So we need to start thinking about that more carefully. So in this case, our friend Aurora, who's a data journalist, knows that we have 3 years of data on hotspots in and around the Meindertsma. So so the conditions that we explored together with AMdEX was, yes, the data is freely available to the Meindertsma community only. If you want access to the data, you have to be part of the community. The data collector says anybody that wants this data, it's crowd data, who owns crowd data, who owns water quality data, who owns the air quality data, it's all free. The AMdEX system will check the conditions, and then Aurora will receive her data set, or data dump in this case, and then she can do wonderful things with the data, like visualizing busyness on the Meindertsma throughout 360 days of the year. Another case is sound data. So in this case, again, it's for the Meindertsma, it's for the community. In this case, the sense makers it's a very passionate group of citizen scientists and makers, and they just want credit for their little smart microphone that they have on top of the entrance. They're collecting all sorts of different sounds, like scooter alarms, car doors, car horns, people screaming, just really kind of interesting urban sounds that can kind of create a profile of what this district of this part of Amsterdam sounds like. So the conditions are met, and then Art Lap. This is one of the sense makers. He's on the roof, and then we have we have some crazy artists on the Meindertsma that wanted to use the urban sounds in a kind of installation piece that talks about AI in the city. So a 3D printed model, and they're shooting it with lasers on sound. It's crazy stuff. But again, this is all possible thanks to the data exchange. And last case is basically just students wanting material to play with. It's really hard, whether it's historic data or real-time data. It's very hard to get access to these things. So there's right now, the Meindertsma is an official swimming area. So the city and the Meindertsma have to ensure quality of water to swim in. And a lot of times with rainstorms, you get a lot of backup. The water can't be treated or processed in time, so you have an E. coli problem sometimes in the water. So there's a water quality sensor now. It's near real time. So every hour there's going to be a status of the E. coli levels to make sure it's all safe. This is expensive equipment. So in this case, Microlon is charging. One of the conditions is 10 euros per month, and that's all baked into the AMdEX platform. If you PayPal account, you pay it, and the conditions are met. And then the in-Holland students can basically use the water quality sensor data, which is near real time. And then maybe what they could do is put LED lights in these swimming lane balls, or design a lotus or some sort of flower to indicate to the public now's not a good time to swim because it's red, right? Or if it's all clean, maybe it's a nice green color or blue color. But these are the kinds of things that we can create together once we start sharing the data, and making sure that the conditions are met, and there's safe exchange and trustworthy exchange of your own data is manageable. So that's our story. I think we have a few minutes for questions. I don't know if you want to join for questions. Any questions about the platform or user cases?
Yeah. Have I got my? Yeah, I've got it on. Well, I've got a question about the platform, I guess, AMdEX. How important is it that to both pretty much people contributing the data, that they know they can trust you and that you're neutral? Have you worked a lot on that, or have you got input on the importance of it?
Well, from the data itself, it's like, since it is a public living lab, you're in an experimentation zone, so by default, the data should be ethical and responsible and even moral, how we collect the data, how we process all the data. It has very strict processing agreements with the city. We have to make sure that everything is citizen-centric and privacy by design, because a lot of these projects are funded by the city. And once you've crossed all of those kinds of checks and balances, the data itself then is pretty safe to share.
Okay, so that answers a question for the Meindertsma.
Yep.
What about if I wanted to get the airlines together, and this, if you extend that out to the corporate world?
So one of the core things that we try to solve is to make these data agreements very easily verifiable. So that's basically why these data agreements, when they're made, they are shared with all parties. So you basically get an email containing your data agreement. It contains digital signatures by all parties involved, and also a digital signature by AMdEX itself. So basically, because you have these 3 signatures, you have a very high degree of confidence that this is actually okay. So it's basically it has a decentralized component, because these signatures could also happen in a decentralized context. But because there is this trusted middleman, AMdEX, you have this added value, because AMdEX can provide other types of checks which individuals would not be able to do so.
We have a question over on the other side.
Yes, first of all, thanks for the very nice presentation. I think, and I may add to your question earlier, if you want to go globally and have global communities, it's also very important that you organize yourself in a community, going back to the previous speaker. So consortia are typically vehicles to bring together user communities that have a common benefit to share the data and also to talk about the access and the usage rights of the data and also possibly monetization, and that ultimately together creates a trustworthy environment. So an exchange should ultimately serve communities in a neutral way and provide the capabilities that consortia need to exchange their data. So if you take it up to the corporate level, I think understanding how consortia would like to use this capability is very important. Just as an addition, thank you.
Yeah, I remember hearing a podcast of the history of the light bulb, and same consortia with all the light bulb manufacturers got together at the turn of the last century to design how the light bulbs would not burn for as long, and the idea was to bring it down so they could sell more. So yeah, probably a misuse of data in that respect. Okay, any other questions for the two gentlemen? No? Okay.